All right, the stuff we will do today. I'm glad we have a Monday to work on this because it is, it's hard, but it's a lot of information. And when we're looking at the rest of algebra, geometry, and the rest of the stuff that you'll do in the math world, this is like the building blocks of everything. So being able to get a good grasp of this one should make everything else a lot more solid, a lot kind of steadier. Can you guys see it? Are there glares? All right, so the stuff we'll talk about today, we're going to do what's called the division property of equality. It's going to make a lot more sense. And then we have the multiplication property of equality. Okay, when I say the word equal, what does that mean to you? Not just in math world, but in like society as a whole. We're going real introspective here.
The same.
The same. Okay. What else could that mean? Like I like the word same. Fair. Okay. Think it needs to be fair. I like it. What does fair look like? What does fair sound like?
Like you get $5, I get $5.
Perfect. Yeah. If we're talking money, if I'm giving out money, you get $5, I get $5. Okay. If I'm gonna use the school one here. If you get caught, Luis, let's just say you're not wearing the right shoes. I'm tired of it. I kept on telling you couldn't. You got the detention. But over here, Hector's now is wearing the exact same shoes that you were wearing, and he doesn't get a detention. How's it gonna make you feel? Pretty ticked off. I like that answer. Math is the same way. Whatever happens to one thing needs to happen to the other. Okay? Just like the $5. If you get $5, I better be getting $5.
Isn't there an AT&T commercial right now with the sucker? Have you seen that?
I'm not, but I like it.
Yeah. Kid got a big sucker, but his sister got a smaller sucker.
I'll show the video on. I know which one you're talking about. I'll show it on Wednesday so you guys know exactly what we're talking about. But yeah, math needs to be equal. It needs to be fair. Okay? So what we're going to talk about with this solving equations with rational coefficients is that whatever we do to one thing, we have to do to the other. Okay? If one person's getting an allowance, everybody better be getting an allowance. Okay? If one person is going to be getting a detention for something, you better be fair that somebody else gets the same problem or same consequences. So when we look at these math problems, when I say that I want them fair, the division property of equality means that whatever I do to one side, I have to do to the other. In the multiplication property, whatever I do to one side, I have to do to the other. Okay, so I'm going to look at this number 1 right now. I'm zooming as far in as I can. When I have a problem like this, the goal for algebra, for geometry, for algebra 2, pretty much all the way through whenever you're working through this stuff, and these will have some story problems to understand where it comes into real life, is that we always want to get that variable by itself. So first off, what is the variable? X. The variable is a letter. I want to get this X all by itself. Okay? And now I'm going to take kind of one of the skills that a student in one of my other classes had showed me that they teach. I think it was at Sacred Heart. But I figured if they had already taught it there, I want to stick with the same strategy that they used. Because if you already learned it one way, there's no reason to learn it 2 different ways. For right now, I'm going to draw a line right down the middle. that tells me that everything that happens on this side has to happen on this side. Okay, just with that $5, we need it on both sides. So I'm going to rewrite this problem, just so that way you can understand what's happening. This side just has a negative 19.6. Nothing has changed about that. On this side, this is actually saying 5.6 times x. Again, when these are put together, there's an imaginary multiplication sign in between it. So when we're talking that math is fair, I'm going to say that a lot for the next rest of the school year. Math is fair. So whatever happens here has to happen over here. Right now, this is saying it's times 5.6. And I want to get that x all by itself. What is the opposite of multiplying? Division. So right now it's being multiplied. I need to do the opposite. So this side has 5.6 times x. I'm going to divide this one by 5.6 because I don't want it over here before or anymore. If I did that 5.6 on the right-hand side, if I divided by that, I have to do it over here. So again, I've got this line that goes right down the middle. Just to show you that whatever I do on this side, I have to do on this side. All right, let me grab my calculator. I forgot it. So on the lesson, on the right-hand side, I've got 5.6 divided by 5.6. What's 5.6 divided by 5.6? 1. 1, or we can just say the x. So it'd be 1x. And if you just wanted to write it as x, that's perfectly fine. Excuse me, because these ones are going to cancel out. Only because I heard it, I want to make sure I specify. It can't be 0, though. Okay? Because anything times 0 turns into 0. So we're not going to turn into a 0, but it'll be a 1. On the left side, I had negative 19.6 divided by 5.6. So I've got negative 19.6 divided by 5.6. Also, this calculators are tricky. It's a negative divided by a positive. What's my answer going to be? Negative. Again, when you start throwing in negative signs, it throws people off. You guys are smarter than the calculator, so you know the answer is going to be negative. 19.6 divided by 5.6. I punched into my calculator. I ended up with 3.5. Is my x all by itself? Yeah, there's just a 1 by it, imaginary friend. I've got an x all by itself. I've got a number on the side. So my final answer is going to be x equals negative 3.5. If you want to rewrite it like this, I'm happy with that. If you wanted to leave it like this, as long as there is a 1 or just the letter by itself. If there's anything else with the letter x, we're not done yet. Because math is fair.
And again, going back to, I like to measure twice and cut once. So if you take that x and you want to check yourself, plug it into negative 3.5 times 5.6, and you should get negative 19.6.
All right, on to example 2. Let me grab a different color pen, just for fun. All right, so I've got negative 20.9y equals negative 250.8. I'm going to do the same thing. I'm going to make that line to go straight down. So that way if I see anything that happens on this side, I have to do the same thing on the other side. Imagine it's like a mirror. I'm just looking at both sides. So currently this one says, just so I can just show it, this one currently says negative 20.9 times y equals negative 250.8. You don't have to rewrite it unless you like to visually see that this is a multiplication problem. If you can just know right away that this is a multiplication problem, you don't have to rewrite it because all I'm doing is just putting that multiplication sign there. So it's saying negative 20.9 times y equals negative 250.8. So I want to get a letter all by itself. So what letter do I want by itself? Y. What's with the y right now? Negative 20.9. How do I get rid of it? Yeah, it's currently multiplying. I'm going to divide both sides by that number. So if I divide this side by 20.9, math is fair. I'm going to divide both sides by 20.9, and I'm left with y equals, I've got a negative divided by a negative. Remember with that one, negative divided by negative, it's going to be a positive. So I get 12 as my final answer. Again, I can leave it like this. I can leave it like that. Or I can rewrite it and say y equals 12. I'm happy with either way that you do it. So far, how you feeling? Okay, you guys are talking me through this next one. New color. Anybody need more time with that one? Sorry. All right, somebody talk me through as if I have no idea what I'm doing. Currently it says negative 13.6a equals 271.6. Hannah.
We'll divide both sides by negative 13.6.
Perfect. Okay, this one I want to get the a all by itself. So Hannah told me I'm going to divide both sides by negative 13.6. Math is fair. I have to do the exact same thing to both sides. So I got 271.6 divided by 13.6. It's a positive divided by a negative. What will my answer be? Negative. There's a reason I'm continually saying the positive and negative thing is because years past, historically, this is where people make the mistake. They just forget about putting a negative in there, or they just kind of fat finger their calculator and they completely miss it. So I got 271.6 divided by 13.6. I'm left off with 19. I must have pushed in something wrong. Like when I typed this up. It's supposed to be a whole number. Oops. No, I got the same thing. I'm saying when I typed up the notes. When I typed up the notes, I was supposed to have a different number. So that's on me. But yeah, I got negative 19.7 where A equals.
It's supposed to be 217.6.
217.6?
Yeah.
All right.
Your dyslexia taking over first.
It's going through. As Daniel's figuring out, they are inside your book as you're going through them. The same review problems, that way if you wanted to look in those ones. Okay, if I did the 217.6, it would have came out to a way clearer number.
It still works.
Anybody need more time? Okay, this one I want you to do all on your own. I got 323.4 equals negative 13.2 z. Or if we're in Europe, z. liking what I see, guys. All right, I'm just going to go through. You guys all did the exact same thing. Because that one had a multiplication, I got negative 13.2 divided by both sides. Math is fair. Whatever I do to one side, I have to do to the other. I get 24.5 equals z. I can leave it like this, or you can rewrite it and say z equals negative 24.5. All right. On to some story problems. So stuff that you'll actually see-ish. It won't be this exact same thing in the real world, I doubt. But it says a 1-year in-state camping permit for New Mexico state parks costs $180. The total income from the camping permits is $8,280 during the first day of sales. I need to know. We're going to write and solve an equation to find how many permits were purchased. How many did they sell that very first day to give them that much money? All right, so I'm looking at those numbers. Any thoughts on how I might be able to set that one up? Daniel?
Do 180p equals 8,280.
Okay, I'm going to write down what you said, and I like it. I just want you to explain as if somebody else might not know. Where did this 180 come from?
How much did each cost?
Yeah, because it says this is the one for each one of them. Where does P come from?
Permits.
Yeah, it stands for permits. You have no idea how many they sold, so you gave it a variable. And this was the total amount of money they made that first day. You did perfect. Absolutely perfect. Now it looks just like those problems we did. Hector, you had your hand raised. How do I solve the rest of it?
So you want to get P by itself, so you divide 180 by both sides.
Awesome. I get P equals 8280 divided by that number. Whoop. Something went goofy on my calculator. Let me try it again. So my P value equals 46. So what's that mean? In regular people terms, after we solve this one, what does that number actually mean?
46 permits were purchased.
Yeah, they sold 46 permits that first day. How you feeling? Give me thumbs up, thumbs down. I love it. Okay, I'm going to read it. I want you guys to do this one on your own then. It says, Esteban spent $116 on boxes of baseball cards. He paid $14.50 per box. Write an equation to find out how many boxes of cards Esteban sold. Reminder, this word per is using that special term to let you know there's going to be multiplication involved. All right, go ahead and set it up. See if you can figure it out. I'm going to turn on the lights for all you solar powered calculator people. Ooh, we're missing one thing. We need a variable. So you write this how much money you spent. This is how much it costs per box. So we're trying to figure out how many boxes he bought total. So we'll need a variable in that mix. Okay.
Excellent.
It's just 50 cents per box.
So I don't care. Don't touch me. Sorry.
If you'd like. So there's a box out here. This would be the same per box. There we go. Okay.
Save it on this one.
You wrote it correctly.
Website.
You said everything correctly. Put it in the box there again. You did backwards the first time. You did 15.5 last time. So that's the right answer.
Oh, come on, Dave.
But again, because you showed me where I can see. So it's just kind of yeah. All right, so as you guys went through it, you had 116. You guys knew exactly that both the numbers went on opposite sides of the equation. The one thing I'm going to draw your attention to was right here. I kind of underlined the per in green. But if it ever says per box or per whatever, that's going to let you know that that is the one. That number is going to be the one that gets to have the variable. Okay? So for me, I gave it a B for the boxes. You could use whatever letter you wanted. You could use a shape if you wanted to. Okay? Because the variables don't have to really mean anything. It's a stand-in. It just hangs out in that spot until we figure out what the number actually stands for. So we got 116 equals 14.5. B, I'm going to divide both sides by 14.50. 14.50. I am left with 8 equals the amount of boxes I bought.
More often than not, your variable is going to go with your smaller number.
Yes.
Most of the time.
Most of the time, yeah. And the other one is I'm going to go back and kind of do what Mr. Rohr told us at the very beginning. I just want to see if this makes sense. He bought 8 boxes of baseball cards. I can take this number times 450 or 1450, and it equals 116. Okay, if I just double check and try to figure out, all right, if I bought, let's say 100 boxes, well, that's way too much. Okay, so just again, see if it makes sense. Plug it back in, double check your answers. All right, on to the second half. This one is going to work just like the ones before. I'm going to show you this one in 2 separate ways. For this first one, it's written 2 ways, so I'm going to show you 2 separate ways. So this very first problem, this one actually says 7 times negative 1/2 times x. So that's the way this one is actually written. Using the rule that we just did, how do we get x by itself?
Divide.
Divide both sides by 1/2. So I can divide both sides by -1/2, -1/2, and then I'm going to be left with, I'm just doing it quick, x equals -14. For all the people in here that have the fancy calculator that lets you do a fraction, that is not a problem at all. For anyone who does not have a calculator that lets you do a fraction, like I'm going to use this one right here. This one does not let you put in -1/2. Okay? There are some other ones that are a little bit trickier to put it in. I'm going to show you another way of how this is doing it. Okay, so let me grab a different color pen to show that we're going to do it in a separate way. So, second side, I got 7 equals -1/2. I'm just rewriting it the same way. This problem is the same as saying 7 equals -x/2. Because again, I took 1/2 times x. This is really what it looks like without using a fraction. So it's saying x is divided by 2. What is the opposite of dividing by something?
Multiply.
Multiplying. So instead of dividing by 2, I'm going to multiply. And I'm going to show you how I write the multiplication stuff. With division, we just put it right underneath it. When we multiply, we put it in little parentheses on the side. This is dividing by 2, so I'm going to multiply by 2. I multiply here, I multiply here. Whatever is on one side has to be on the other. Math is fair. So 7 times 2 is 14. I've got a 2 divided by a 2. So those numbers cancel out. But I've got this sign that I have not gotten rid of yet. You see how the negative was up here, started here, and then here, and I saw it here? I want to get the x all by itself. I don't want it to be negative. How can I get rid of that negative sign? Divide by?
No, divide by 14.
You were so close first time. Divide both sides by -1. Yeah. I can, whatever I do to one side, I'm going to do to the other side. There's a negative. I'm just going to divide both sides by -1. -1, -1. That just turns this into a -14 and this into a positive x. Again, if you can set it up as a division problem, the opposite of division is multiplication. Okay? We got the exact same answer. I'm going to let you know, sometimes it is easier, and actually I prefer to do it this way. It's easier for me to go this way because on my calculator, I can guarantee I can look at every step that I'm doing and I can follow it. If I put fractions into a calculator, it is so easy to mess things up. Okay? Questions on that? We're going to go over another one. All right, I'm going to rewrite this problem so you can see it. I've got 6/7 times m. And then I've got -3/14. Does anybody remember, this has been like 4 chapters ago, what it's called when I turn my fraction into like the
Reciprocal.
opposite? Yeah, the reciprocal. Okay, I'm going to multiply that by the reciprocal. Again, we had a division problem, and now we're going to multiply it by the opposite. So I want the letter M all by itself. So it's saying 6/7 times M. What is the reciprocal of 6/7? I want somebody new that hasn't talked yet. Austin?
7, 6.
7/6. The reciprocal is the fraction flipped around. That side was times 7/6. This time, or this side is going to be multiplied by 7/6. Math is fair. Whatever you do to one side, you have to do to the other. Okay, if we're multiplying by the reciprocal, they cancel each other out. All I'm left with over here is going to be an M. Who remembers how to multiply fractions? Austin?
Is it like cross multiply?
So cross multiply is only for on opposite sides of the equal sign. But yeah, I'm glad you're remembering. So this would be like that cross multiply stuff where they cancel each other out. If they're on the exact same side, we don't cross multiply.
Multiply straight across.
Straight across. Straight across the top. So I've got -3 times 7 is -21. And then 14 times 6, that's going to be, I don't want to screw it up and say it wrong. So I'm going to, is it 84? So I got M equals -21 over 84. Am I done yet? Simplify. Yep, we can simplify that one down. Excuse me. They can both be divided by 21, actually. Excuse me. But I can do, again, if they're simplified here, I can do the exact same number on both sides, or on the top and the bottom. So my final answer gets to be -1 over, should be 4, right? Yeah.
Can we also cross simplify on the top?
Yeah, if we wanted to go through before you, tell you what, I'm gonna take this spot here. I'm just gonna move it over.
Because me, that's what I would do. I would cross simplify so I don't have to deal with those numbers. But that's just the way my mind operates.
All right, we're gonna go Doctor Strange style, multiverse of madness over here. All right, I'm rewriting this problem from this step right here. I got 7/6 over 6/7 times M, and then that equaled -3 over 14 times 7/6. I went with Doctor Strange because I got a feeling none of you guys remember Wayne's World. We go, doo-doo-doo-doo. Judging by your faces, no one has seen Wayne's World. All right. I'd like to say you're not missing much, or you're missing something, but you're not missing much. All right. So doing what Mr. Rourke was saying. Okay, there's a 3 on the top, there's a 6 on the bottom. This turns into a 1. This turns into a 2. Okay, there's a 4 and or 17 and a 14. These ones both have something in common. They both are divisible by 7. So that will turn into a 1. This one will turn into a 2. And then following through with what Mr. Rourke said, these ones canceled out. So again, 7 on top, 7 on the bottom, 6 on the top, 6 on the bottom. I'm left with M equals, then multiply straight across. 1 times 1 is 1. 2 times 2 is 4. To be honest, I like the way on the right as well. I just know when we did some of the quizzes, there were lots of people that got confused by that process. So whichever one makes more sense to you, by all means go for it. But either way, we're still gonna get the exact same answer. And if you want more help practicing doing it this way, ask Mr. Rohrig, ask myself. Because again, it is one of the faster ways to kind of cancel those things out without getting the headache later on. All right. Question 3, you guys are telling me what to do. I got -9. I'm going to rewrite it again. -9 equals 1/3 times n.
Divide both sides by 1/3 to get the n by itself.
Yes, we'll divide by 1/3. We're going to go that whole entire way. Using the way that we just talked about before, that reciprocal. Let's do the reciprocal. But yes, it'd be divided by 1/3. Or we could say divided by 3. Okay? So what's the reciprocal on both sides? 3/1. Let me draw that line down. Today's my day. I pretend like I don't know what, or this is the question I pretend I don't know what's going on. What do I do now?
Multiply straight across.
Okay, I can multiply straight across. So -9 turns into 9/1. Multiply straight across. Tell me, Gabe, how do I multiply straight across?
3 times 9 is 27.
Okay,
-27.
-27
Over 1.
over 1. If it's over 1, I don't have to write it.
And 1 times 3. Right?
Yeah, but because we did the reciprocal, they can cancel each other out, right?
Yeah.
So what's left off on the right-hand side?
N.
Just an n. Final answer. Again, math is fair. Whatever you do to one side, you have to do to the other. Very last problem. This one is on your own. And then we're going to go on to the assignment. I've got -1/4 equals 2/7. Or sorry, 2/7 y. So with that one, it doesn't give you this. Yep, the graphic calculator don't have the ability. So it's, here's what we have to do a longer. Just to make sure we're not,
We gotta keep fractions. You're gonna push yourself up.
awesome.
The decimals. It's so much easier fractions, okay? Stick with fractions. This is fractions.
So instead of dividing by, we're gonna multiply by the reciprocal. Because yes, if you don't have a calculator, you can do it without having it. So since on the outside, we'll put 7 for 2. And then same thing on that side. Whatever you do on one side, you do on the other side. 4. So if you multiply straight over, it was. Okay. These are the last one. We see that last. Where my straight across the top. What's that? Those two steps will So that's in the bottom. Plus -7 over. That's your answer. That's it. Yes.
What you guys get?
Can you go over one like this? Is
Yep,
it
don't worry about your
this
name.
example? This one's just
Yeah.
like the homework with 3 numbers. Or do we just multiply this one then?
Okay.
So.
2 over 7 times that. We're gonna multiply by 7.
Yeah.
7 over 2. So like whatever this one is, we're just gonna flip that upside down.
Hey, where?
Yep.
Well,
So I think you just take all negative 4 times.
And now for this one, we're gonna multiply the top numbers together.
36x. Solve them all.
Yep.
I'm pretty sure I've seen the answer.
That's negative 7. So those are the ones getting out. That's fine.
Well, you said mid-quarter, so third quarter.
Good.
March something.
Okay, I'm gonna write this one down. You guys had it. I love what I saw. Again, some of these ones, it was just a while since we have last done reciprocals. So 2/7, the opposite of that is gonna be 7 over 2. Both sides, 7 over 2. So I get, there's nothing to cancel out. So I've got straight across the top, 7 times 1 is 7. 2 times 4 is 8. These ones cancel out. 2 and a 2, 7 and a 7. So I'm left with y, forgot to draw my line, y equals -7/8. Your assignment, guys. Again, ask for help if you need it. I also wrote this one a little bit different. I wanted to give you a smattering of problems. It's a fancy word for you. So your assignment, and it's going to look weird, but it's on page 327. I want you to go 12 through 40 by 4s. Okay, so if you need to write it down, you can, but it'd be like 12, 16, 20, 24, 28, 32. So it's a total of 8 problems. And you have one story problem mixed into that. You got this, people.